Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 26, Episode 74, for broadcast on the 21st of June 2023. Coming up on SpaceTime, the BepiColombo mission undertakes its third Mercury flyby. Rare earth metals discovered in the atmosphere of a glowing hot exoplanet. And a new study suggests the Earth may have been built a lot faster than previously thought. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
As we go to air, the BepiColombo's spacecraft is undertaking its latest close flyby of the planet Mercury, passing just 236 kilometres above the baking hot planet's surface. This is the third of 6 gravity-assist flybys of Mercury being undertaken by the joint European Space Agency and Japanese Aerospace Exploration Agency spacecraft. The flybys, together with more than 15,000 hours worth of challenging solar electric propulsion operations, are needed to help the spacecraft fight against the enormous gravitational pull of our Sun, in order so it can eventually lose enough energy to be captured into Mercury's orbit in 2025. During this close approach, BepiColombo is arriving on the night side of the planet, meaning the most interesting views of Mercury's surface will be recorded by the spacecraft's monitoring cameras. While it's a welcome opportunity to snap images and fine-tune science instrument operations at Mercury before the main mission begins, the primary reason for the flyby is to use the planet's gravity to guide BepiColombo's path through the inner solar system. The mission, launched on an Ariane 5 rocket from the European Space Agency's Kourou spaceport in French Guiana back in October 2018. And it's making use of 9 planetary flybys. There was 1 of the Earth, 2 of Venus, and now 6 of Mercury, all needed to slow it down enough to achieve Mercury orbit insertion. Now, after this flyby, the mission enters a very challenging part of its journey, gradually increasing the use of solar electric propulsion through the use of additional propulsion periods known as thrust arcs. These are designed to continually brake against the enormous gravitational pull of the Sun. Now, these thrust arcs can last from a few days up to several months, with the longer arcs only interrupted periodically for navigation and maneuver optimizations. Mercury is the least explored rocky planet in our solar system, with one of the main reasons being that getting there is really difficult. As BepiColombo gets closer to the Sun, the powerful gravitational pull of our local star accelerates the spacecraft towards it. Gravity-assist flybys are a great way to change course and slow down without using a lot of fuel. But they're also far from simple. Mission managers need to precisely guide BepiColombo so that it passes Mercury at exactly the right distance, from exactly the right angle, and at exactly the right velocity. Now, all this was calculated years ago, but it needs to be as close to perfect as possible on the day. ESA flight dynamics expert Frank Budnick says as BepiColombo starts feeling Mercury's gravitational pull, it'll already be travelling at 3.6 kilometres per second with respect to the planet. Mind you, that's just over half the speed it approached during the previous 2 Mercury flybys, so it's slowed down a lot. But to be captured by Mercury, we need to slow down even more, and so scientists use the gravitational pull of the Earth, Venus and Mercury in order to do that. Mission managers have already performed the largest chemical propulsion manoeuvre of the mission so far. The purpose of that was to correct errors in BepiColombo's orbit that had accumulated as a result of thruster outages during the previous 1.5-month-long slow electric propulsion arc. Correction manoeuvres on the approach to a flyby are all part of normal operations. Without these, BepiColombo would have been some 24,000 kilometres too far from Mercury and on the wrong side of the planet. To be on the safe side, and to ensure there's no chance that the mission could end up on a collision course with Mercury, this latest manoeuvre was designed so that BepiColombo would pass the rocky planet at a slightly higher altitude than needed. The extra margin was a good bet, and cancelled out previous errors that had crept into the flight path as the spacecraft traversed millions of kilometres of space. Now, at the moment of closest approach, BepiColombo will have accelerated to 5.4 kilometres per second with respect to Mercury, courtesy of the planet's gravitational pull. Overall, the flyby will reduce the spacecraft's velocity magnitude compared to the Sun by 0.8 kilometres per second, and it will change its direction by 2.6 degrees. This mission marks the first time that complex solar electric propulsion methods being used to get a spacecraft to Mercury, and it represents a big challenge for the remaining part of the cruise phase. And while all this is underway, mission managers have been dealing with the COVID-19 pandemic back on Earth. They've also had to deal with communications delays of more than 10 minutes due to the time it currently takes signals to travel between the Earth and the spacecraft. While many instruments have already been activated during the cruise phase, some will also operate during this flyby, providing another tantalizing glimpse of the Mercury science expected during the main mission. Magnetic, plasma and particle monitoring instruments are sampling the environment before, during and after closest approach. And this is also the first flyby for which BepiColombo's laser altimeter and the Mercury Orbiter Radio Science Experiment are operating. Once in Mercury orbit, the laser altimeter will measure the shape of Mercury's surface, and the radio science experiment will investigate Mercury's gravitational field and core. Collecting data during flybys is extremely valuable for science teams in order to check their instruments are functioning correctly ahead of the main mission. It also provides a novel opportunity to compare with data collected earlier by NASA's Messenger spacecraft. It visited Mercury between 2011 and 2015. Once it arrives in Mercury orbit in December 2025, BepiColombo's two science modules, ESA's Mercury Planetary Orbiter and JAXA's Mercury Magnetospheric Orbiter, will separate from each other and the Mercury Transfer Module used during the cruise phase, and they'll then enter complementary orbits around the planet. Because of the configuration of the spacecraft during this cruise phase, the main science camera has been shielded and will remain so until the spacecraft modules separate. But during the flybys, snapshots are being taken by BepiColombo's monitoring cameras. During this closest approach, BepiColombo's in Mercury's shadow, so the illuminated part of the planet only entered the spacecraft's field of view around 13 minutes after closest approach, when BepiColombo was already 1,840 kilometres away from the planet and moving away fast. It means there were no illuminated images from the closest approach itself. The cameras do provide black and white snapshots in 124 by 124 pixel resolution. But because of their position on the spacecraft, these cameras are also capturing other things, one of the Mercury Transfer Module's solar arrays and one of the Mercury Planetary Orbiter's antennas. But the planet itself will be there in the background. This report from ESA TV.
Allumage de EAP, décollage.
The BepiColombo mission to Mercury is off to a successful start. Within hours of launching from the European spaceport in French Guiana, the spacecraft had unfurled its antennas and two 15-metre solar arrays. Monitoring cameras even took some selfies, showing one of the solar panels and two antennas. A few days later, the spacecraft deployed a 3-metre boom containing sensors to record magnetic fields. The sensors have already returned their first data. Images from the NASA Messenger mission are the best we have of Mercury. It has highlands and lowlands like other planets, but unlike Earth, Mercury rotates on an axis perpendicular to its orbit.
Due to the fact that Mercury is not tilted, there are some craters on the poles where the sun never shines into it. And inside these craters, MESSENGER found water ice. It was detected even earlier in the 80s from ground that there were rather bright spots, and there were some hints that it might be water ice. But now from MESSENGER, we are pretty sure that we have water ice in craters. And that's pretty much surprising. Think about if you have a planet on the surface 450 degrees, and then you have water ice at the poles. It's kind of unbelievable.
Fortunately, there's an instrument on board called MERTIS, which can measure the surface temperature directly to see if it's cold enough for water ice. Knowing the makeup of the planet's dark surface is also important. A team at DLR, the German space agency, have built a special chamber to heat up samples to examine how they behave at high temperatures. These can then be compared with what will be found on the planet. Planetary scientists are unsure how it formed. It could have originated beyond Mars, with an impact pushing it closer to the Sun. Or it could have formed at lower temperatures in its current position. If so, current theoretical models will need a rethink.
And one of the things why I like working on Mercury is we need to understand Mercury in order to understand how planets form. If we have a model that forms all planets but not Mercury, that model is basically useless because you need to get that one as well.
NASA's MESSENGER mission did a great job, but BepiColombo consists of 2 orbiters using complementary orbits with more combined instruments. Plus, unlike MESSENGER, it will obtain high-resolution images of the entire planet. The planet is also shrinking in size, possibly due to cooling. Plus, there may be active volcanoes, so there is much more to learn.
Mercury is a very mysterious planet. Every time we went there, we found new surprising results. And that is the reason why we do BepiColombo. And we hope with BepiColombo, on one hand, we are able to answer many of these new questions. But I'm pretty sure we found a lot of new surprising results which raise new and other questions which we then need to follow up.
BepiColombo arrives at the planet in 2025. Then, for this joint mission from ESA and the Japanese space agency JAXA, it will be time to unlock Mercury's mysteries.
This is SpaceTime. Still to come, rare earth metals discovered in the atmosphere of a glowing hot exoplanet, and a new study suggests the Earth may have been built much faster than previously thought. All that and more still to come on SpaceTime. Astronomers have discovered rare earth metals in the atmosphere of a distant glowing hot gas giant exoplanet. Exoplanets are planets outside our solar system that are orbiting stars other than the Sun. Since the discovery of the first exoplanet in the mid-1990s, over 4,000 have been found. And of these, KELT 9b is the hottest exoplanet known to date. A report in the Astronomy and Astrophysics Journal and on the pre-press physics website archive.org shows that the planet KELT 9b contains signatures of gaseous iron and titanium in its atmosphere, together with traces of vaporized sodium, magnesium, chromium, and the rare earth metals scandium and yttrium. Located some 950 light-years away in the constellation Cygnus the Swan, KELT 9b exemplifies the most extreme of the so-called hot Jupiters. These are gas giants, usually in close orbits around their host stars, sometimes within orbital periods less than a few Earth days. In the case of KELT 9b, its host planet, KELT 9, is almost twice as hot as the Sun. Therefore, the planet's atmosphere also reaches extreme temperatures, often around 4,000 degrees Celsius. That's hotter than the surface temperature of many stars. Now, in such heat, all elements are almost completely vaporized, and molecules are broken apart into the constituent atoms, once again very similar to the outer plasma layers of stars. Now, this means that the atmosphere contains no clouds or aerosols, and the sky is clear, mostly transparent to the light of its star. Now, the atoms that make up the gas in the atmosphere absorb light at very specific colours or wavelengths, and this provides scientists with a unique fingerprint or spectra of the planet's atmospheric chemical composition. Using the HARPS North spectrograph on the Italian National Telescope at La Palma on the Canary Islands, the study's authors initially found iron and titanium atoms in the hot atmosphere of Kilt 9b. And follow-up observations not only confirmed the original detections, but also found evidence of additional elements. In fact, the survey included 73 atoms, among which were some so-called rare earth metals. These are substances which are less common on Earth but are applied in advanced materials and devices. One of the study's authors, Kevin Heng from the University of Bern, says the team suspected that the planet's spectra could be a treasure trove containing a multitude of elements that have not been observed in the atmospheres of other planets before. After careful analysis, the researchers indeed found strong signals for vaporized sodium, magnesium, chromium, and the rare earth metals scandium and yttrium. Heng and colleagues were also able to use these signals to estimate the altitude in the planet's atmosphere where these atoms were at, and they were able to observe strong global wind patterns high up in the atmosphere, blowing this material from one hemisphere to the other. Heng says with further observations, many more elements might well be discovered on Kilt 9b, perhaps also on other planets heated to similar high temperatures. This is SpaceTime. Still to come, a new study suggests the Earth might have been built a lot quicker than previously thought. And later in the Science Report, a new study confirms that China and Russia are rapidly expanding their nuclear stockpiles. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
A new study claims that the Earth was created much quicker than previously thought, and it came complete with its water, a sort of package deal. The findings, reported in the journal Nature, counter the commonly held scientific view that it took hundreds of millions of years for the planet to form, and that its water supply arrived later by way of comets, or more likely asteroids. We know that, like the other planets in the solar system, the Earth was formed by the condensation of gases into dust grains in a protoplanetary disk around the early nascent Sun some 4.6 billion years ago. These dust grains began clumping together under static electricity and gradually grew bigger, forming pebbles and then boulders, which clumped together with other pebbles and boulders under their mutual gravity, eventually forming hot magma ocean-covered protoplanets. And over time these would slam into each other, accreting together to form the proto-Earth. Then around 4.5 billion years ago, a Mars-sized planet called Theia slammed into the proto-Earth, melting the whole thing back into another magma ocean, which eventually coalesced and cooled to create the Earth and Moon system we have today. In this scenario, presence of water on Earth was a sort of chance event, created during the late heavy bombardment period, which lasted from the Theia impact until around 3.9 billion years ago, and during which time meteors, asteroids and comets were flung towards the inner solar system and consequently the Earth by the outward planetary migration of the two gas giants Jupiter and Saturn to their current orbital positions. However, the new study suggests a quicker alternative. The study's lead author, Martin Bizzarro from the University of Copenhagen, says his research shows that the early accumulation of small millimetre-sized pebbles happened very quickly, taking just a few million years. Bizzarro says once a planet reaches a certain size, its gravity in orbit acts like a sort of vacuum cleaner, sucking up all the dust in its path very quickly. And that makes it grow to the size of the Earth in just a few million years. This vacuuming up of small dust particles not only played a vital role in Earth's formation, but also made sure that water was delivered to the planet. That's because these protoplanetary disks also contain lots of icy particles. As the vacuum cleaner effect draws in the dust, it also captures a portion of the ice. This process contributes to the presence of water during the Earth's formation, rather than relying on asteroids delivering the water 100 million years later. Pizarro and colleagues reached their conclusions by studying silicon isotopes in order to understand the mechanisms and timescales of planetary formation. By analysing the isotopic composition of more than 60 different meteorites and planetary bodies, they were able to establish the relationships between rocky planets like the Earth and Mars and other celestial objects. This approach allowed them to determine the type of building blocks that assembled to form the Earth and the process by which they came together. Pizarro says the findings, if confirmed, are important because they tell us something about planets outside our solar system as well. With this new planetary formation mechanism, the chances of finding habitable planets in our galaxy is much higher than previously thought. See, habitability is the potential of a planet to have the right ingredients at its surface for life to develop. And one of the key ingredients for habitability is liquid water. Pizarro says his hypothesis predicts that wherever you form a planet like Earth, you will have water on it. If you go to another planetary system around another star about the same size as the Sun, then any planets in that system at about the same distance as what the Earth is from the Sun should have water on its surface. This is SpaceTime.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can in the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a Science Report. It's been revealed that Santos' retired Legionnaire oil and gas field off the Pilbara coast of Western Australia has been leaking gas into the atmosphere for decades, and governments have done nothing to fix the problem. The revelations by the environmental group Friends of the Earth indicate that methane gas is leaking from 26 locations in the field. Methane is a major greenhouse gas, 80 times worse for global warming than carbon dioxide. Friends of the Earth campaigner Jeff Waters says these methane leaks aren't being counted in the national greenhouse accounts, even though Labor and Liberal governments have known about them for years. Waters says the covering-up's an outrage and likely to be just one example of many. He says the real question is how many of the 90 or so retired gas fields around Australia are also leaking. Waters says if Santos can't clean up its own mess, then engineers from Europe should be brought in to solve the problem, and Santos should pay for it. A new report on the strength of the world's nuclear weapons arsenals is showing that China and Russia are both expanding their nuclear stockpiles and doing so by far more than any other country. The latest assessment by the Stockholm International Peace Research Institute comes as global geopolitical tensions continue to rise, following the Russian invasion of Ukraine and China's ongoing aggression against Taiwan and its other neighbours. In fact, the biggest nuclear weapons increase was in China, which saw its stockpile rise from 350 to 410 thermonuclear warheads. Russia's nuclear stockpile also grew from 4,477 to 4,489 in the wake of Moscow's announcement that it was suspending participation in the START nuclear weapons reduction treaty. India, Pakistan and North Korea have also increased their nuclear stockpiles, while intelligence reports warn that Iran is now close to testing their first nuclear weapon despite continued denials by Tehran. The total number of confirmed nuclear warheads among the 9 known nuclear powers now stands at 12,512. Of those, 9,576 were located in military stockpiles ready for use. That's 76 more than a year ago. Scientists have developed a single-dose injection to stop cats getting pregnant. A report in the journal Nature Communications claims the injection delivered a specific hormone known to suppress the maturation of ovary follicles. Scientists found the gene therapy injection was able to prevent ovulation in cats involved in a proof-of-concept study, and they found no adverse reactions even 2 years after the injections. AMD have launched their new 9754 and 9734 Super Bergamo processors, which will be used in computers, data centers, and artificial intelligence. Technology editor Alex Sahara of Reut from Tech Advice Start Life is in San Francisco for the launch.
AMD has been a thorn in Intel's side for about 50 years. They were actually the first company to reach the 1 gigahertz processor way back in the day when we were still living in the land of the megahertz. And although Intel did launch its Core i3, i5, and i7, throughout much of the 2000s and the 2010s, they kind of coasted. And AMD's technology fell behind. And about 5 years ago, they launched the Ryzen processor on the Zen architecture. And they have taken the fight to Intel in an incredible way. They've been pushing the state of the art with the x86, both in desktops, laptops, and servers. And let's not forget that it is AMD who makes the processors in the PlayStation 5 and the Xbox consoles. So they do an extremely great job at pushing forward graphics and computers that are dedicated to games. And in fact, even Asus had their new ROG Ally, a little handheld Nintendo Switch-style device, running on the AMD Z1 Extreme processor, which does an incredibly good job at delivering desktop-class power in a handheld device. So at this launch, they launched the new EPIC 9754 and 9734 server processors, codenamed Bergamo. And these are designed specifically for cloud-native computing workloads. This is a 1.5-hour keynote. You can go to AMD.com. You can watch the keynote. They also had the 9004 series processors with new 3D V-cache technology, which is also for high-performance technical computing. These are computers for data centers. And the big thing they launched last November was their EPIC 4th generation series, of which these processors are an update to, and deliver 20-30% improvements just from 9 months ago. But the big change with Zen 4 was that one AMD-powered server could do the work of 5 Intel servers at half of the power consumption. And a lot of demanding applications are licensed per server or per processor. And if you just have one processor in one server that did the job of 5 servers, you can cut down on your costs for the licensing, but you can also cut down on your energy costs by a huge amount. You've got a 100% performance boost from the 3rd gen to the 4th gen. That normally takes several generations to achieve that sort of an uplift. Then the data center manufacturers have all this extra space that they can put new technology in. They've got space back and they're lowering their costs. So AMD also launched something called the Instinct MI300. These are AI-enhanced, AI-specific processors. They can run an entire Falcon-based 40 billion parameter large language model, the LLM, that is powering things like ChatGPT and Google Bard. They can do that on one processor, one computer. I mean, people like NVIDIA, one of AMD's biggest competitors, they actually just hit temporarily a $3 trillion valuation because a lot of their chips are used to power these AI data centers. So AMD has given data centers the ability to install these AI-focused servers, and they're also the first x86 processor maker to include a specific AI neural engine. We hear about them for iPhone chips and Android chips, but we've never heard about it for x86 processors. So we've got the AMD Instinct, which has got this advanced accelerator for generative AI, but they also have the new desktop and mobile processors, the 7040 series, some of which come with this AI enhancement. And at first, what they're talking about is pretty basic stuff. They're talking about how it will easily blur your background on video calls. It'll allow your eyes to be looking as though they're looking at you, even though you're looking down at the screen, so it can reposition your eyes. And also gives you this extended battery life. And in fact, they were even able to compare it against a MacBook Pro 14-inch running an M2 Pro processor, so not the M2 Max or the M2 Ultra, but the M2 Pro. And they were claiming an additional 15% of battery life. So AMD is doing some pretty amazing stuff to keep x86, the Intel type of architecture, the Windows architecture chips, more powerful, more relevant. They're kicking Intel's butt. They're doing deals with HPs and Lenovo's and Dells to get many more computers out there with AMD. And they're leading in the data center, and they're doing special work on AI. All these things we rely on. All our apps are all hosted in data centers. We're using more AI than ever before. So AMD is coming out at the right time with the things companies need to upgrade to the next generation.
That's Alex Zaharoff-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.